I'm trying something new today. Again, it's a new Desmos activity that did not exist before. So I'm trying to incorporate some more of these so you can do some discovery learning. What we're going to be doing today, hopefully for just the first 20 minutes, my goal would be that we're done with this activity by 10:15. Okay, so that would be our goal. We want to do some investigations about circles. So we have, the problem in here, like I said, the Desmos activity didn't exist. We're not really going to worry about this 9-1 problem, but I want you to think about this for a moment. If I have a can of tennis balls, right now I only have one tennis ball because I don't know what happened to the other ones, but if I take out the tennis ball, or if I know that the can is pretty much exactly the distance around, if I wrap a string around this can, right? Just around. Or even if I cut off the label, you can even think about that as opposed to wrapping string around it. How would that string wrapped around compare when I stand it up? How would the length of the circle's edge, right? Because a string around the can would be like the edge of the circle, compare to the height of this can? By the end of our Desmos activity, you should be able to tell me. So in, actually, I think I'm just going to have to launch it. You don't even have to be in 911. Really, if you just go to student.desmos. Stop, that's unnecessary. I don't even know you. You're from Virginia. Meet Virginia. All right, so there's your class code. Student.desmos.com with S's, not Z's. $5SQ. I don't like 5s and S's together. Mine look too similar. 6HC. 5 sandy quarters. 6, I don't know. 6 hungry caterpillars. Oh my gosh, that was one of my favorite kids' books. Hungry Caterpillar. Anybody? Because it has the hole that goes all the way through it. What do you mean it's so long? It's a great book.
No, I meant just everything.
Well, yeah. Also, rainbow fish. My sister-in-law has rainbow fish tattooed on her arm, actually.
Oh. I like drawing the rainbow fish.
Well, so what's the idea behind the rainbow fish story?
Be different.
Well, he starts out different, right? People don't not that people don't like him, but it's kind of weird that he's different. But then as people need scales, he shares his scales with other people. So it's all about giving yourself to help others. It's a really good moral story. All right, anyone need more time, or are we logged in? What's up? Oh, he's not killing himself. He's just giving little pieces of himself. It doesn't hurt him. Well, okay, if we think about it as an actual fish, now we're over analyzing because we're not 5-year-olds, we're 7th graders. Are we good? Are we in? Okay, come on, please, hurry, please. And then you're gonna want out a piece of paper. That's we will be taking notes at some point, so you can go ahead and get that out if you want. Once you're in, I think you can go ahead and start. I don't think you have to wait for me. So I'm going to go ahead and screen capture this and put it up on the smartboard. So I'm going to, for anyone playing along at home, I'm going to stop the video while we do this activity. Well, yeah, I kind of need to so that I can see the screen. So I'm going to stop the video, and then we'll start it back up here in a minute. So this is as you guys work. So really what we care about is your answers to 4 of saying, what would you need? Is it letting you do 4? Here, I'll open up 5, too. It doesn't matter who you are. I'm going to open up 5 also. I'm just curious about your answers for 4. I'm curious about your answers for 4. Does your black dot pop up with numbers? No. I think it does later than that. Oh, you got numbers. Yeah, guys, if you click on your black line, it will pop up with numbers. If you click on your black line, it will pop up with numbers if you want that. Hey, if I'm going to leave this screen up, one straightforward rule, no picking on cops during this activity, so no picking on like spelling or any of that stuff. If there's a spelling, if there's a typo or anything, just don't worry about it. Like no snickering, like, who spelled that? Like, we're going to leave it anonymous.
I love the names.
Right?
Joseph Leo. I know who
Richard
I am.
Dedekind.
I know it, I am.
Alright, so if I want to turn off my restriction and let you guys like continue on this activity. If we talk about 1, 2, and 3 and like what struggles we had or what successes we had and why, like what 4 asks, what would we like to know, right? What other information would help us get better answers? What do you think? What else? So people are saying I would need to measure the circle's circumference. I don't even know what that means. That's a fancy word. It would give me a rough estimate of how far it would go. Joseph Louis, though, he knows what's going on. Measure the circle's circumference and use my fingers to try to see how it would play out. Yeah. The outside of the circle, circumference, how far it goes on half a spin. Yeah, I like it. All right, I turned off the pacing. You are unrestricted. So then, go figure, we start to give you more information. Remember, math books equal pizza. Start next Wednesday. Start Wednesday. Or sometime later. Sometime. When it works well. So maybe it can't happen or something like that. That's a very creative answer from whoever has ever restayed Galois. You can also agree, kind of.
I get it. You have to move back.
This is somewhat similar to Pear Deck. You guys are going to be using in global cultures, where like we can see other people's responses. I believe it's today. So if we look at Joseph Louisville, just because he's right up here, each measure of the circle x multiplied by 3 is basically right next to the point. What a coincidence that pi starts with a 3. I like their little sense of humor there. What a coincidence that pi starts with 3. Is it a coincidence, though? Keep working. Keep working. What? I know. I like it. I like your sarcasm. I knew it was sarcasm. But I like how you phrased it. Like, oh, what a coincidence. We're dealing with circles, and pi starts with 3. Like, I wonder if there's a relationship. I get it. I like your... I don't know if I'd call it a sense of humor. I like your delivery. How you say things, Brayden. I noticed that the thicker circle, probably the bigger one, the further it goes. Yep, that spelling is slightly off. If the circle was as big as the dot, how far would it go? Huh. Yeah. Ooh, John Wallace. I wonder, or I noticed the diameter times pi is how far it goes. I wonder if I'm right. Some good answers. Ooh, about 3.4. I'm not sure about that. Pretty close. Take about 6 more minutes. Ooh, right out the bat, we have a couple different answers. Now I will make the request on your homework with the pick 6. Try to pick problems that seem new, like they're using some of your new knowledge and new skill set. Don't, because it's review, preview, right? Don't just pick review problems. You're like, oh, I've done these. I can do these. Great. I'm going to do the easy ones. It's your practice for your benefit. We are going to have a mastery next week before we head out to break over exactly what we do this week. So however far we make it this week, that's what is going to determine what our mastery is. Ooh, I got somebody typing an answer in terms of pi. Ooh, I got one answer that seems to stick out. Galileo Galilei seems pretty high compared to the other ones. When you typed in the word pi, it changed it. Yeah. Connor said he noticed when he typed in the word pi, Desmos converted it to the symbol, which is true. Yeah, Desmos is really smart. Has Marin said that's sexy?
No, it's zesty.
Oh. So there's this dude. When I grade your papers, I often put on like disc golf because there's a YouTube that covers disc golf pro tour, and the commentator's name is Nate Sexton. Like that's his name, so that they call it Big Sexy Commentary. Which is funny because disc golf is such like a nerd sport.
Found a disc golf story over there.
Was it the one down on Riverside?
Yes.
Yeah. Disc Mart.
Uh-huh.
Maybe I can get them to sponsor my YouTube channel. Alright, take 2 minutes and try to wrap up as much as you can. I'll leave this activity open so you can continue to come back to it if you want to. To take a couple minutes to wrap up what you're doing, and then we are going to come back together. Cross equals pi done. Cross equals pi done. Then, as you wrap up your thought process on that activity, I want you to think about my initial question about the tennis balls. If we want to know about the length of that string, oh, major thanks to Braden, my calculator destroyer. He has replaced our calculator with a more friendly looking calculator. Stapler. I looked down here and I saw a calculator at the same time, and the mustache is just throwing me off. So, Braden, we're going to need to decide what his name is. So, get back to me later. We'll decide his name. Alright, let's come back together. I want to know if anybody has an answer to my question about the tennis balls. So, well, they're as big as the can. The can is as big as them. If we take a string and we wrap it around the can, right, which is essentially the same size as the tennis ball, how would that string compare to the height of the can? Does anybody have a hypothesis? Now, you might want to ask yourself how many tennis balls are in a can? 3, right? What do you think if I took this lid, right, so we were working with circles up there, 2-dimensional circles. What if I Sharpie a little dot, like your dots that you were working on up there? And we were to take this, and we were to lay it out just like you did in your lab, and we start it at a point. And then I roll it until that black dot gets back to the bottom. Somebody tell me again. There. How does that distance compare to the height? Or, alternatively, if you want to view it a different way, if I start at the top and I roll down this way, how's it going to compare? What did you guys find out through that lab? Or was it a waste of time? I don't know.
Pi.
What about pi? Cherry?
If you multiply the diameter by pi, it gets the circumference.
Okay, so if we multiply the diameter by pi, it gets the circumference. That still doesn't answer my question about the can of tennis balls.
Wait, what? What? No, yeah,
if it was for a piece of candy, what's your prediction? Will the string I wrap around the can and cut just to be able to wrap around the can, will it be shorter than the can, as tall as the can, or taller than the can? Mallory?
I think as tall as the can.
Why?
Because I don't know how to put it.
Don't know how to put Savannah?
I think it's gonna be taller than the can because when you multiply, in the lab we multiplied it by 3, but since it's by pi, and since pi is a little bit over 3, it's like a little bit over 3 times whatever the diameter is.
So this is gonna be tough, but in your notes, draw a can of tennis balls.
Yeah. That's hard.
So draw a cylinder, right? The height of this cylinder it's 3 times the diameter, right? Because the diameter is distance across the tennis ball. How many tennis balls fit in the can? 3. Right? 3 stacked. It's a 3-pack. I don't have them all because I gave them to somebody. I had all 3. I don't know where they went. But my can, now forget the bottom part, right? We're going to ignore that. But my can is 3D tall. If I wrap something around the can, so then, I don't know if you can with dotted lines to represent around back, show like wrapping the can. What would that wrap around it be? What would that circumference be? Micah?
Diameter times pi.
Now we normally say the pi first. What's pi? Approximately. 3.14 times d. Is the string taller than the can? Yes. By that 0.14d, that is how we end up taller than the can. So that string would, in fact, if it wraps around the can, it's taller than the can. So here's the other application of this. Imagine a lake that is perfectly circular. And you are walking on a trail and you just run into the lake. If you have to take the path around to keep on the trail, let's say like the river flooded or something and you can't take the normal trail, what will this be approximately compared to that? So that we said is our diameter, right? If we approximate, how does this length compare to the diameter? Gwendolyn? Yeah, it's going to be approximately 1.5 times the diameter. Now, that's not accurate, but approximately. If I have to walk around something, 7th graders like to complain. You could complain, oh, I have to go extra distance. I have to go 1.5 the distance I would have gone. But if I have to go around the whole thing, and this is the rule that we want people to get more familiar with, yeah, pi is accurate, but approximately, can you write on your paper approx to abbreviate approximately? Approximately, the distance around a circle is 3 times the distance across. Accurately, so sorry, this should be squiggly equals. Since we're approximate, that should be squiggly equals. And then if we do the exact formula, and this is in your book, crust equals pi dough. Have I taught that in here yet?
Yes.
Yeah. The crust of your pie is pi dough. That wasn't a very creative. Yeah. Stole that from Danica McKellar. She is math teacher / actress. If you put on any of those holiday or Lifetime or Hallmark or Lifetime movies during the holidays, you'll probably see Danica McKellar on one of them. I have a couple books from her. The female mathematician that is also an actress, kind of an interesting character mix there. Yeah, I'm not making this up. I don't know exactly how it all happened. But she writes books towards girls. I think I've plugged that in here before. And, like, they're funny for boys, too, but she, like, is writing towards a middle school female perspective. Like, when she writes these books. So we have our formula. So I'm skipping through some problems here because we did that activity as opposed to the actual lesson yet. So one thing that we've done in the past before we had that Desmos activity was if we went around the school and gathered data of circular objects and compared the measurement around them to the measurement across them, we'll find that relationship, but it's really hard to measure around a circle, right? Like it's just hard to measure round objects. Let's go ahead and close your Chromebooks for now. Go ahead and log off. And calculate this real quick. If we're just asked to calculate the approximate circumference, make sure that you check with your teammates on what your answer is there. If we're just asked to approximate. Let's look at how different an approximate value is compared to the exact. So you're going to need a calculator to compare exact to approximate. I know. I'm going rogue. So the approximate, yeah, is times 3, right? Approximately 27. If we do the exact, it's pi, not 3. And on your calculator, you have a pi button. So right over here on the left-hand side of your calculator, that is saved in your calculator a bunch of digits of pi. I don't know exactly how many, but a lot. So if you want precision, don't just type 3.14, use your pi button. However, if a problem says use 3.14 for pi, there's a good reasoning behind that. We'll talk about that in just a moment. So if I use actual pi here, what do I get? Connor?
9 pi is what I divide by 1.0 and I get like 28.2743.
Sorry, what did you say?
I did it in times 0.1 out.
Yeah, so that was because calculator setting. By you doing that, it pushed it into a decimal form, so I like what you did. It's absolutely perfect. So 28.274. Why? Sorry, go ahead, baby. You sure? Why do we use 3.14? Anyone know? Like, I don't expect you to. I'm just curious. I'm always curious if you guys know things. Brady?
Because when using it, it gives you a 3-digit answer with the decimal, so it's easier to...
Yeah, we like 2 decimal places, right? By your 3-digit answer, we might have like 28.2, like it's okay if it was 28.27, like, you know. If we use 3.14, we'd probably get 28.27. We like 2 digits in the decimal places. What if I told you to write out all of pi?
It's not possible.
Right there.
Sorry, what, Octavia? There has been, for a long time, I don't know exactly why, a competition for who can remember the most digits of pi. People memorize millions of them. I'm never going to ask you to do that. But the reason that this can be made into a competition is pi is this special type of number called irrational. So please write down in your notes, pi is irrational. meaning there's no, right here, no ratio form. However, right, as mathematicians like to do. I don't know how to describe this. At the point that you tell people you can't do something, what do you think that makes happen? They want to do it, right? As soon as you tell somebody, like, yeah, you can't do that, somebody's like, yeah, watch you, right? Now, sometimes that's a really bad idea. Like, you can't jump from that building to that building. Don't do that. Please don't try to, don't do that. But so they told mathematicians, right, pi is irrational. We've determined you cannot make a fraction for it. Somebody type in 22 over 7 in your calculator. 22 divided by 7. It's not the same thing, but it is darn close. So 22 over 7 is 3.14. 287? 2857, sorry. Alright, and then I'm going to cut it off there. If we talk about how close this is, where does it start to not be the same number? The 2, right? What place is that? Thousandths place. And it's only off by, well, actually, if I grab both of these, the 2, 8, that should be 15, right? Those two places. So that's off by 13 10,000ths. That is close to pi, off by this much. That's ridiculously close. So while there is no fraction form of pi, mathematicians took the struggle, and actually, these are pretty small numbers. There are bigger number fractions that work better, quote unquote, but for this, using such small numbers, it's darn close. So 22 over 7 is the approximate fraction form of pi. Connor?
Aren't there other irrational numbers that aren't famous? Isn't pi only famous because of how it's named and how it's commonly used?
So, if we want to actually define what pi is, which is a really good question, look at 9/6. So that was if you try to analyze the relation, if you were asked to represent pi in another way, like, what is pi, but don't say 3.14, don't say 22 over 7. If you were asked how do we check if a circle is a circle? Like, you're given a round object, and you're told, like, determine, is this actually a circle? And you have them at, like, you can measure things. You can do all that.
Circumference divided by diameter.
If we know that crust is pi dough, right? Circumference is pi times diameter. Then what Micah just said was if I isolate the pi is actually always circumference divided by diameter. Because that will always get us pi. So if you're given a circle, imagine I hand you this tabletop, right? And I'm like, check, is this a circle? Measure your circumference, measure your diameter, do the division, and if you don't get pi, it's not a circle. This sure looks like a circle to me. But if you don't get pi, it's not a circle. Questions?
What's pi, the symbol? I'm always wondering why did they come up with that symbol?
It's a Greek letter. So actually, they stole the Greek letter after determining they needed a symbol to represent it. So pi comes from the Greek alphabet, which actually, if you want all the Greek alphabet letters, every year we have this conversation, so I actually keep this printed. Here's your Greek alphabet in actual reality, like alphabet, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, pi, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega. That's your Greek alphabet, right? Learned that in college. Pi is just one of many symbols that you'll start to see more and more of these used through science and math. You've seen delta used anywhere? The triangle?
Lots of places.
What's it stand? What do we use it in science for? Like if you see delta temp or delta time, or delta is used for change in. The delta symbol, the Greek symbol, and it's just a triangle, but it's used for the change in a value. What else do we use? Yeah, and I think we stole psi also. Sigma, this one right here, the weird looking E, sorry, down here. And there is an E, so don't get that confused. But sigma means to sum. Hey, gravity works. So if you see a sigma, then what you do with it is add up everything that comes after it. So there's a lot of Greek symbols that we use in mathematics. Let's do this problem real quick, and then we'll get out of here. Sorry, they're changing early. Don't know why. So if our diameter of the Earth at the equator, right, if we measure through the Earth, is 7,926 miles. Journey to the center of the Earth thing. What is the measurement of our circumference around the equator? Because that's at the equator, distance through the Earth. What would be the circumference at the equator? Somebody punch it in real quick. Braylon, you got it? That is a mode issue. So if you are getting answers in the terms of pi, then you need to go to mode and go down to classic, I believe. Yeah, if you go to classic, not math print, you select it just with the enter. If you go to mode, go down to classic and hit enter, so you're in classic. You should be in degrees, normal, float, and classic. You should be all on the left in your mode. Then type in 7,926 pi. You get 24,900 miles, guys. If you were to take a trip around the equator of the Earth, you'd travel almost 25,000 miles. Yeah. And then we can do some fun math with that. Like if you do 60 miles an hour, how many days would it take you, or things like that. But that's all the time I got. Have a wonderful day, guys. Choir people, remind them that the video's up, or they can come see me if they have issues. But really, it's just reinforcing circumference. Yes, it is an oblong spheroid. You are correct. But if we look at it two-dimensionally, in certain views of it, it can look pretty darn close to a circle.